Hi, I'm Chris. I'm CG supervisor at M2 Animation Studio. M2 is a studio located in Denmark, in USA, and we have a full service building in Bangkok when we are big, 200 more people, 200 more artists, and that's where I'm working. We are specializing in script-to-script animation, and we've been doing mostly animation for kid content until 2020. And since 2020, we've been doing a lot of content for Warhammer, the famous franchise from Game Workshop, where Space Marine fight across the universe for the Emperor, them and pretty much everyone else in a war that never ends. And that's my company. You can see the logo here. And we're going to watch a short trailer about our work. Let's go. So that's Warhammer, and it's all done and rendered in Unreal. And it all started with this orc. This guy is an orc from 40K franchise and is an orc from our first trailer that we did in Unreal. It wasn't initially planned to be done in Unreal. It's back in 2021. We are still in the midst of the COVID pandemic. You remember? It looks like it's completely forgotten, but it was during that time. And we had to render that. We had more and more Warhammer project coming among kid shows. And there was just one problem with that show, is that we don't have any render capacity anymore. It was impossible to find GPU, so we could not increase our render farm. We could not render that movie at that time. So we have to think fast and find some solution. Some adventurous people at M2 conducted some tests with Unreal and came back very quickly with some promising pictures, and decision has been done to render that movie in Unreal. And it was the start of the adventure. Note that the show, the 2-minute trailer was already half done in Maya. All the assets were done, all the animation, the Lookdev were all done. It was just ready to render, except that it was completely in Maya. And it was about bringing that to Unreal. That was a very funny time. At that time, I was just FX artist at M2, and it was very funny to see that no one had a clue how to use Unreal. But eventually, I had a little bit of experience. I started learning Unreal a few years prior to that because I love video game, and I always wanted to do my video game. Turns out I'm better at playing video game than actually doing it. But it's a subject from another talk, maybe with a psychiatrist, about my game addiction. Anyway, so I offer to help to bring that trailer in Unreal, and that was the beginning of the adventure for me. I started building some tools. That's where I started developing some tools in Python, because it was about transferring hundreds and hundreds of assets. It was very, very heavy. So yeah, I had to build some tools that eventually became a small pipeline, and along the years until now grew up, evolved, and up to a full-fledged pipeline with tools at every corner of our production. I'm going to show you a graph to impress you. Ta-da! Are you impressed? That was only the goal for that. There is not much to it, except that on top, on a horizontal line, we have like a classic pipeline, CG pipeline, going from Maya pipeline, going from asset, animation, lighting, and render. So like I told you, we're not going to lead and render that show anymore in Maya. We have to bring that in Unreal, which is like a similar pipeline, except that it's in Unreal. And between Maya and Unreal, we have the server. And at M2, we have a Maya-based pipeline with already Python API. Like most of CG company, Python is at the heart of every CG company. So we already have a server, and we already have some tools that export classic assets, Maya file, Alembic. So it's just a matter of nudging the the pipeline so that you are able to export the different formats that are going to be used in Unreal, and you can have a hint already of what we're going to export: FBX, JSON, PNG, and Alembic. And eventually, when we render here, we send back the EXA on the server, and we go to celebrate the end of the project. And let's start with how we transfer assets from Maya to Unreal. We're going to start with FBX. I love FBX. It's a natural format for Unreal. It's light, it's flexible, it's fast. I like it. So we use mostly FBX for everything: geo, static mesh, skeletal mesh, animation. And Alembic, yes, we do use Alembic only when we don't have other alternatives, or only when we have to. So close simulation, some effects when the geo change every frame, then we use Alembic. But the rule is we try to avoid it because it's heavy, right? It's going to add some data in your project. So that's about that. But FBX had some limitation, especially for assets and asset texture. It doesn't have the ability to carry the texture description for the asset. There are some feature to embed some textures, but that's not good. Textures are compressed. It's so very limited. I think it's limited to 2 or 3 textures, like base color, a normal map, and one more. We can't use that. So we need something more to carry that. We need JSON file, and Python is the best friend with JSON file. So what if for every asset we have a FBX that contains the geo, and we also add a JSON file that contain the texture attachment for each shader attached to the object. We have the description of what texture is being used for every component of that shader: base color, normal, roughness, and where that file is on the server. So that's a binôme, FBX and JSON file, that contain all the description for each asset. And two-part scripting. So if I come back there, you can see how two-part scripting is needed. We need a first part that exports the asset onto the server, and a second part that imports. So that's really two different part of scripting. I'm not going to focus on that part because it's really dependent on your DCC. It can be Maya, it can be Blender. Basically, there are scripts that export FBX and whatever you need. I will come back later on the specific of the FBX for animation. They are a bit peculiar, but I'm not going to linger on that. We're more going to linger on the second part of importing assets in Unreal and the tools that we use in Unreal in the pipeline. So let's move on. And let's talk a bit about Python. I really love Python because it has interconnection with everything. Like I said, we already have a Python pipeline at the heart of M2. And if we have a Python pipeline in Unreal, we can talk with this Python API that we have. That's very convenient. We can use tool or features that we have there. And that's very convenient. Also, we can talk with other parts of our pipeline. Here, I watch ShotGrid for every CG studio. ShotGrid is very important. You know what it is, right? The project management tracking system by Autodesk. It has its Python API, and so we can talk to ShotGrid from Unreal, Perforce, etc., etc. So yeah, I already said that. We can leverage our own Python API. At M2, we call that MIM. Don't ask me why. Asset management, I really want to talk about that. To me, it's very important that in the Unreal project, we have asset management. What I don't want is artists to drag and drop FBX in the project manually, drag and drop anything. You can be sure they're going to put that everywhere, and you're going to end up with an Unreal project that does. I like my asset at the right place with the right name. So for that, you need scripts. There is no other way around. So when our script import the asset, they put them at the right location. Note that if you build other tools that are going to need to locate these assets, well, you need these assets to be at the right place, or else you're not going to find them. Python API easily carried in all projects. So Python in UE is obviously not at runtime. It is slow. You don't want that. And yeah, it's not at runtime. It's only in editor. And you can use that more or less like in two ways. So you can build a Python library, a repo with all your code, your UI, put that on the server, and from the Unreal project, call that library, and that's it. Yeah, basically to set Python in your project, you just need to call that library. It's very convenient. You have another project, you just set the path and you have it. No need to migrate any asset, no need to compile any asset. This is very easily deployable. The other way is to use editor utility blueprint. It's a special class of blueprint in Unreal that comes in two forms. One can do stuff on assets in the content browser, and the other do stuff on actors in the level. And they both come with the same mode of action. You right-click on when you want to work on asset or actors, and you see there is a script action menu, and then you see the function that you define in your blueprint. And in this function, you can use blueprint nodes and snippet of Python. Very nice editor utility blueprint. Who use that here? Yeah, perfect. The perfect guys, you. All right. And can build your UI with PySide. Very convenient. Again, you have your UIs built in PySide as a UI file. You add that in your library and you're happy. And let's start with our first core UI that we build. It's not Persona, it's not Clair Obscure. We're not going to win any contest with these graphics, but it gets the job done. That's all we need. What it does, it lets you import assets that are available to import. So it looks on the server. If there are some FBX, it's going to list it there and let you import. You can import static mesh or skeletal mesh. So the artist come here and import the asset. And let's go and have an example with one asset and what the script does. And here we take as an example the shovel asset. For Warhammer, that's a very important asset. It's kind of a private joke. You don't want to mess with the shovel asset, all right? Or the guardmen are not going to be happy. So the shovel, sorry. Like I said, we have two files on the server. We have the FBX and the JSON file. So the JSON file contains a small dictionary with the name of the material and where are the textures associated to every component of that shader. Here we have the metallic texture, the normal map, the base color, and the roughness. So when you click import, the script is going to import the static mesh in the right place in your UE project. Here the shovel is a prop, so it's going to put that in static prop shovel parts. Then it's going to also import all the textures used for that asset, and then it's going to do the extra mile. It's going to open the material and reconnect the texture. How can is that script? Then I did not mention, but there is also a post process, and that's very useful when you import every asset. It set stuff. So static mesh, I'm thinking about high precision UVs or nanite fallback mesh settings, all these kind of small things that you're happy to set automatically, and the artists don't have to think about that. That's more time to do something else. And that was the shovel. And now we're going to dig a little bit into Python. I'm sorry for people who are, but I could not talk about Python without showing a little bit of Python. And first thing, I want to thank someone, because back in 2021, when I started doing some Python, there was not too much info on internet. It was a bit wild west. And if it was not for this guy, Alex Quevillon, I would have struggled much more. Actually, this code I didn't even come up with. That's his code, so I have to thank him. Right? This code is basically two things. The first part, build an asset import task. This is this thing, Unreal asset import task, and take as an argument the file itself, what file you want to import. And what's great with this function is it's completely agnostic to whatever you want to import. You can set a PNG, you can set an FBX, an Alembic. It doesn't care. It is agnostic. Then where you want to put that file, the destination name, destination path, and some option here. So these options are, I'm gonna come back in the next slider to that, let you define more precisely what you are importing. It is agnostic, but it needs to be guided to know what exactly it is importing. But interestingly enough, if you import a texture, you don't even have to set any option. A PNG, you just import that PNG and it's going to import it. Very convenient. And then the second tool here is just executing that import task. So the function that is being used here is the Unreal Asset Tool Helpers, get asset tools, import asset task. And this one simply execute the import task and import the asset, and eventually return the path of the imported asset if it's success. All right. Yeah, I was mentioning about the options. So you just precise as an option what you are importing. So if it's an FBX, you're going to use that object, FBX import UI, that you can also further detail whether you want to import like a static mesh, a skeletal mesh, or an animation sequence. It's going to be using that object. With the option, you can define an ABC import settings if you import an Alembic. And that's the last thing we use. Now we also import a groom cache as an Alembic. Another thing you can import, that you can import anything with that function. And eventually, I just here put an example of how to use that. It's simple. You just build the import task with the file you want to import, and you execute it. So yeah, pretty simple. Now that we have our assets, static mesh and skeletal mesh, let's dive a little bit on the set dressers. And I'm not going to linger too much on that, because here we are really using a feature of our pipeline. Like I told you, we have already a Python pipeline at M2. And at M2, Maya set dress are merely a JSON file. They are merely a dictionary containing the list of every asset and their position, the transformation matrix of Maya, and that's it. There is just that. So if we have that, it's pretty simple to use that feature in Unreal. And here we have the Palace of Terra. It's located on top of the Himalaya, and that's a very important place for Warhammer. And this is the set dress in Maya. And when we end up having in Unreal everything lined up, we are good. So like I told you, a set dress is just a list of all the assets, and their transformation matrix is just a JSON file with the list of assets. So we can use that easily. When we are back to the import asset UI, this UI also lets you deal with set dressers. On the left, sorry, here it lists all the set dressers of the project, and the tools that I build are also agnostic to project. Here you could choose another project for anything, it's going to work. But here you select your set dress, and it's going to look up the JSON file and just see the list of the other assets that are needed to build that set dress. It's going to list them here, and it's going to do the extra step of telling you if the asset is already imported in your project. So here they are green. It means you have all the assets that are needed to compose this set dress. If not, it will be white, and then the artist will have the ability to import it if the FBX is available. And once you have all the assets, you simply click import set, and the script is going to build a level and just put all the assets back together. We also have the option to use an instance static mesh, so that's just regrouping all the static mesh into one object using instance static mesh component, or not. You can have all the assets flat. That's up to you. All right. Note that as we moved on and used more and more Unreal Engine, we found out that it was very convenient to build set dress in Unreal. It's very nice, set dressing in Unreal, right? You see the asset, you can import Megascan. So because we are still animating in Maya, we need to get back the set dress in Maya. So of course you can export everything as an FBX, but that's quite heavy. So eventually we have a functionality that does the reverse engineering of what I explained to you. It's going to export each asset and register them in our pipeline. And then it's going to build the JSON file so that Maya can use them as any regular setdress in a nice way. Here we have GPU cache, so it's not going to be heavy in Maya, and we all know that Maya is Autodesk. I'm going to go briefly on Lookdev workspace for Surfacer in the Unreal project. It's more a strategy than a real coding, even though there are also a lot of script for them. They have the ability to build a turntable per asset. So they select an asset and it's gonna load the turntable level, spawn the asset in it, create the sequencer, create the keys to rotate the asset. We also have some feature to have multiple light sets being lined up in the sequencer. So they have one rotation on one light set, then another rotation on another light set. So they can look dev with multiple light set scenarios. And they have also the ability to render automatically with some default turntable preset published on ShotGrid. I'm going to come back to that later. But the idea is the Surfacer, they are very early in the Unreal project. They work on the static mesh. The skeletal mesh is not available yet. And the idea is that they're gonna finish the surfacing on the static mesh. So all the materials are gonna be in the static mesh space. And when we get the skeletal mesh having the same material slot is simply gonna pull all the materials from the static mesh. So we have a script that look up all the material slot, and by comparison, I'm gonna pull the materials. It's convenient, and it's a good strategy because I remember at the beginning, it wasn't clear where we do surfacing, and we ended up having some materials in both static mesh and both skeletal mesh place. So because in the project we separate the two, it's good to keep the surfacing in one location. So yeah, just a bit of strategy. All right, so we have our assets, we have some set dress. Now we can move on to the shots, which is really the heart of our work in animation, right? So that's a shot in our latest project, Saturn 9, characters, camera, and again, we're gonna have scripts that do many things here. A shot basically is just the basic bricks are a level and a sequencer, shot 10 sequence. And with further fragments, a shot in multiple logical components that are themselves level that we're gonna stream, all right? So we use level streaming to stream shots that are animation, lighting, set dress, and effects. Each of these components are separated levels. And for animation and effects, there are levels that have their own sequencer, all right? All of that is being bring in the main level and in the main sequencer. We have ability for this shot to bring the animation. So both importing the animation, I'm gonna expand a little bit on that, bring the animation sequence, so import the FBX and drop the animation in the animation sequencer, which is very convenient. Again, one thing you don't want to do manually, you don't want to spend your life dragging anim sequence in the sequencer. It's good that you have script that does that. We also have the ability to update that anytime. In a production, everything is moving constantly, camera are being updated. So we need script that updates that. And it's good to fragment your shot structure so that you can work on each compartment separately. When our script updates animation, it's merely work on the lighting, the animation level and the animation sequencer, okay? It doesn't touch the lighting. So it's a logical separation of elements, right? And here is the UI that they use. So yeah, it is a bit horrible. I know. Again, we're not going to win any contest and we win that. But and it has dramatically evolved. For the orc trailer that I show you, it was like this, and with the years, it kind of pushed. This UI lets artists set the shot. So set shot, it creates the levels and the sequencer in the UE project automatically. Here you choose your episode, your shots. It has option, and I'm going also to expand on that, of importing some lighting scenarios, a little bit like I show you for Surfacer. So here it's about having some levels in the project that contain lighting actors. And here it's merely copying the asset of this lighting preset into the lighting shot level. Okay, each shot has its own set of lights. We decided that because it lets the artist to completely break the shot the way you want. It's also practical to work on actors in the detail view and not a blueprint. Like if you want to access the lights in a blueprint, it is convenient like that. They also have the ability actually to choose other shot. Let's say they did a great job on shot 10 lighting. This here has the ability to pull the lighting from one shot and use that on other shots. All right, so yeah, I'm going to come back on that because it has a cool feature, ability to stream some set dress. So here they are shared set dress among the projects. So these set dress are just streamed. And like I told you, we have buttons to update every component of that shot. All right. Yeah, this is the anatomy of a shot at a level. We have a space for each shot. It's like I told you, the basic component, a level and a sequencer. And in these folders, we have other levels that are being streamed here in the main level. And in the anim folder here, that's where we're going to have the anim level, the anim sequencer, and all the anim sequence of a shot. When the script brings the anim sequence, it brings it here. I don't have a picture, but you can imagine. The sequencer, so that's the shot sequencer here. And here is the anim sequencer. This is the part where the script work on its own. So it brings animation sequence for the characters and all the props. Here we have some clause as alembic that is also being dropped by the script. And the anim sequence is being pulled into the main sequencer via a subsequence here. So like that, you end up with some sequencer that is not too bloated. We know the sequencer tends to be bloated quite easily, so it's always convenient if we can get things clean. Some subsequence for animation, for effects. So FX artists also have their own sequencer that is being subsequenced here. And yeah. Yeah, the script also set the playback for the sequencer. So here we query ShotGrid. So again, we use the ShotGrid API to query how long is a shot, and then we fill the playback automatically in the sequencer. I'm going to come back a little bit on that. Import anim. I need to discuss a bit about that. Like I told you, we use FBX for animation, and from Maya, very important, we only export skeleton data. Okay, I don't know if you know about that. It's not something that is documented too much, but I'm pretty sure by now most of you already found out. When you have animation with blend shape, you don't have to export the mesh as an FBX. You can bake blend shape data onto the skeleton, so that you can export the only skeleton and you don't have to export the mesh to get back the blend shape data. It makes FBX very light, and it's something that is not being told. You have to figure that a bit on your own. So eventually we figure that, and we have FBX that are light. Okay, blend shape parameter being baked in skeleton. Yeah, so the script first imports the FBX into the shot space animation. So we have animation sequence for every character. Not that I discussed about asset management. That's another example of asset management. When from Maya we export the FBX file is being named with the name of the asset inside. We have the character name. So that when we import that back in Unreal, you know, when you import animation sequence, you need to target a skeleton. What the script does that for you. He look up the name of the FBX, he see the name of the asset, and then he go to fetch the skeletal mesh. And because it's managed, because it's at the right place, he's going to find it for you. So you don't have to target skeleton because you click forever. All right. So I come back on that feature that I discussed, the ability to update the lighting scenario. So yeah, we have a space with some light set presets. So there are levels that contain lighting actors. And so if you want to do that manually, you know, you just open your source level, you copy and paste. What if you want to do that programmatically? The idea here is to stream the source level. And I don't know if you know, but when you have stream level, you can move the actors from one level to the other, okay? So that's how we do here. That's what the script does. There is just one glitch with that, is that when you move the actors from a source level, it moves them, which means there is nothing left in the source file. So that if you do that programmatically, you're going to end up with an empty level source, and Unreal is going to mark that as dirty and ask you to save an empty level, and you don't want that. So there we go, a bit of Python text. So what if instead of streaming the source level, we copy it into a temporary level that we can destroy, manipulate the way we want, delete when we're done. So here we use this library here and this function uuid4 .x. It makes a very silly name. It's a 128-bit hexadecimal number. You can be sure that it's going to make a map that no one has named like that in the world. Huh? So yeah, you are safe with that. So you duplicate the source level. So you have your lighting scenario that you want to get in your lighting level. First, you duplicate it as a temporary map in a temporary place in the project. And so that's going to be, I'm sorry about that, the most techy portion of this talk. I will try to make it fast. So, but if there is one very, very cool thing in this code is the first line. I spend hours skimming through the codes to find it. What if you want to get the in your level, you have a stream level. What if you want to get them programmatically? Well, you have to use that Unreal gameplay statics get streaming level. And don't ask me why they choose to put that in gameplay statics. It doesn't make sense at all. It's absolutely misplaced. I found it completely randomly by scrolling endlessly in the API documentation. And yeah, so if you ever need to get a streaming level programmatically, remember gameplay static, and that's going to save your life. So when programmatically you add a level in when you stream a level, you have this function here, add level to world. Okay, and here you define the streaming method. You know, stream level can be loaded by blueprints or streamed by blueprints. So we are always stream. So because we always want the level to be a stream, we use that. But here, that function return the stream level. So when you add a level, you get that. But if you want to get the one that are already stream, you're gonna need this one. So here we get the lighting stream where we want to put the lighting scenario actors. We stream our temporary level with its silly name. Okay. Here there is a loop. So what we want to do, we want to move the actors of the temporary level into the lighting level. So we need to select them. There is just a small catch, is that at the moment, all the actors are going to be visible. So there is a loop here that basically hides other actors from other levels that you don't want to be bothered with. And so this loop is there, don't mind too much. And once they are hidden, then you can select all the actors of the level. That's going to be your your actors that you want to move, and use this thing, editor level. It is move selected actors to level. This is exactly the action of right-clicking, and when you say move actors to selected level, and then you remove this temporary silly level from the queue, and you can delete it. All right. Okay, this one I'm not going to spend too much time because I'm sorry, I know it's boring, but work programmatically with sequencer in Unreal is very easy, whether you want to look up or you want to create or add some binding. You need to remember three things. You need to manipulate bindings that have tracks, that have section, all right? So a binding, you already know what it is, a binding in a sequencer, right? It can be processable, it can be spawnable programmatically to create, I'm going to move to the second part, to add a spawnable or a processable, it's almost the same. You add processable. And you define what kind of binding you add in the sequencer. Here, object to process a skeletal actor is if you want to create a binding for an animation sequence, all right? And once you get that binding, then you have to create a track that's eventually the track of the sequencer. And you need one more thing, you need a section. And that section gonna contain the range. It's also gonna contain the parameters for the path for the anim sequence as well, or all the detail basically of that binding. But remember that binding, track, and section. And if you want to look up that, it's gonna be the same. You're first gonna need to get the bindings of the sequencer, then get the tracks and get the section. All right, I hope I did not lose you too much. I'm really sorry about that. Okay, and finally, we are ready. We have our shots, so they are lit. We need to render the shots. Again, we have a set of tools here that do many things. Yeah, we work with MRQ, with a movie render queue, and I'm going to spend a little bit of time of the preset that we use to render our movie. So we use Lumen and we use Unreal we use hardware ray tracing. We use temporal sample for nice motion blur, and we use TSR. One important thing, so we export AXR. We do use a Cryptomat, but that's it. Also, important thing, we disable the tone curve of Unreal. I don't know if you guys are familiar with that, but that's almost like a plague. If you want like a clean color management in your project, you want to disable that tone curve, or else basically you write AXR with that color correction is baked on. And you want to avoid that. I recommend the video from William Fauché, that does a very recent tutorial about color management in Unreal. And I salute Philippe, our director at M2, that cracked that already a long time ago. Prop to him. All right, so the render shop, that's the UI. So what we need to do, we need a script that set the jobs for you in the MRQ, in the movie render queue. So build the job, manage the preset. I'm going to expand a little bit on that. Set the output path for you. Again, asset management. We don't want the user to have to look for where to save the files. And a post process that once the render is done, do stuff. What we do as a post process, so we export AXR, we convert AXR into video, and we publish on ShotGrid. Okay? And eventually we transfer the AXR onto the server. You remember at the end of the pipeline, we go back onto the server and we go to the bar to have a drink after that. Okay? Like I told you, the script build the job for you. Select the preset. I come back here. We have some default presets for the project. a go-to preset, quality preset that artists can use. We also have the ability to make shot presets. So what it does, it's going to create a preset file inside the shots that eventually is going to be used next time we render that shot. Obviously, you're going to have different presets per shot. Some presets, you're going to need some console variable. You're going to need to work on pre-roll for FX artists. So you want to be able to have shot presets. It's very useful. The script obviously fill these two places. I'm going to show you that it's going to be the last Python tech part. It's going to be very fast and easy, this one. And that's it, yeah. Here it saves the AXR. It makes a movie file. So we use a Python FFmpeg to convert the AXR into a video file. And once it's there, then we publish onto ShotGrid. And yeah, and we are happy. Okay, that's going to be the last Python tech detail. It's quite simple for MRQ. You're going to need to use this object here, the Unreal Movie Pipeline Queue System. It's going to let you create the job. It's going to let you deal with the preset. It's going to let you fill the level and the sequencer, do the output settings for you. And the interesting part here is there. This line here, render queue with executor, is the act of rendering the shot. So it's basically when you click render, that's what it does. And even more interestingly, that line here, on executor finish, delegate, add callable, unique, you can define a method, a Python method that is going to be executed after the render. All right, so that's the callback function. And that's finished for Python detail. I would like to add a few things, a few heads up about, so since 5.5, there is an interchange, the new framework for importing assets. And I haven't tested in 5.6, but in 5.5, the FBX support is experimental. My script still works, but I found out some weird stuff. So eventually you can disable that FBXing, and for the time being, I'm going to do that. Note that when you look in the documentation, there is apparently, you can find some Python script where apparently they use new object to import asset. There is now an interchange manager to import that. So there might be some new Unreal moves fast, right? So we have to adapt fast. I would like to thank some developers. I would like to thank Pei from M2. You remember the part of the first part, scripting the export tools from Maya. Pei did a lot of that back in 2021. And I focus on the import script in Unreal. Thank you, Pei. I would like to thank my good friend Mostafa Ari, who helped developing a lot of the tools that I showed you today. And on that, I'm done with my talk. Thank you very much for listening. Any question? Hello, Jack.
Chuck, can you talk a little bit about your fur pipeline, like fur grooming?
About?
Fur grooming pipeline.
Ah, okay. So we have used hair cards in quite a lot, and Mott can talk about that. But we tend to try to use the curve-based groom pipeline. So coming from Maya, we export Alembic for the groom itself. And for hair simulation, I suppose that's what you are interested in. So we have multiple options. When we can, we stay in Unreal. So for instance, for short hair, you can easily tweak the physics to have like nice wind on short hair. It's not costly at all, very, very easy. You need to tweak a little bit of Niagara for that. For some groom, you can also rely on the physics in Unreal, but it has some limits. You're not going to be able to have the most accurate simulation with that, but it can get you somewhere. If you want some real simulation, you can sim in Maya and export the Alembic cache. Okay, as yeah. One advice though, these caches are very heavy if you sim all the curves. We found out very recently that you have the ability to export not only the groom, but the guide curves for the groom. And eventually, you have the option to sim only these guide curves and export as Alembic. And that's going to be it. So you end up with an Alembic that is small because you have only simulation of the guide curve, and the rest of the groom is being interpolated around these guide curves. So quite a nice system if you have CFX artists, and I know you do. So yes, that's we use a combination of technique. When we really need some quality, we sim in Maya, and else we rely on Unreal physics that has some limitation at the moment, I find. Yeah.
Another problem we have is when we render fur in Unreal, it takes forever.
It depends how much fur you have and what machine you. Alors, I would say maybe you use settings that are a bit too expensive. The hair, what Unreal does, it uses voxelization, which basically turns the hairs into a volume that is used for shadowing and lighting. So you have to be careful. I know if you want quality, if you want hair to stop flickering, you can increase the resolution of this voxel, but that's when it can end up becoming slow. I'd say that we can push the number of fur quite high. It does come at a cost, but yeah, I'd say take care your render settings for the groom. Yeah.
Thank you very much.
Hello.
I was just looking at your the way you structure your levels within. Oh, sorry, sorry. I was looking at the level structure for your sequences, and I see there is animation, lighting, set dressing in there. Does that mean you use possessables over spawnables, or is it a mixed bag?
Yeah. We do use possessable. For the animation, we use possessable because for a long time we actually connect the groom onto the actor, so we wanted to have the actors. Not that being said, there is no reason not to use spawnable. Actually, it should be used as much as possible. We actually don't need these levels. It's good to have them if we need them. I'd say it's just like a precaution, but we could actually, again, programmatically adding a spawnable is the same as a possessable. It's the same, except that you don't have an actor in the level. It's just the sequencer that does spawn that. Yeah.
Okay, thanks for that.
Hi, thank you for the talk. So, in my point of view, the way you ambient annotation can be upgraded nightly to use the universal distribution. So why didn't you use it?
USD?
Yeah.
Oh, I will stick with FBX because FBX you import it make a U asset. It goes straight into an Unreal format that is, I think, more direct. I think when you use your USD, you have a layer, so you don't have like a. I don't know. I like to work with US to see my UAsset file to have like a native assets that are proper to Unreal. So that's why we did not bother too much with USD at the moment.
Use the other USS stuff.
Yeah.
There's a web script to do that.
All right. Well, let's talk about that later in the dev launch. Yeah.
Sorry. So far you show us that the tools that you built in Unreal, like the Python tools, all have like a separate interface. Is there any way like to integrate it with the, let's say, right-click menu inside the assets, the Unreal assets? Let's say,
A way to?
like I mean, is there any way to create like a Python script that directly interact with the assets? Let's say you want to have like a insert menu inside the Unreal menu.
Okay. So that's how the startup script. So I mentioned in the Unreal project setting, I mentioned you can give a path to your Python API. There is also a field called the startup field where you can define a Python script that actually contain all the menuing. That's where you build the menus item. Okay, so that's the startup script, and yeah, I can show you that.
Okay,
yeah.
so it's on the like in the top menu, or like it's like
Yeah,
the right click.
yeah. If you go to the Python section,
Yeah.
you will see the startup section where you can point to a Python script that does all the menuing and have some nice feature.
So it's
actually.
all the same with the like I'm talking about the menu inside the like the assets, not like in the top bar.
No. That's I talk about a menu in the main editor. Yeah.
Is there any way like to create like a button inside, like when we doing like a level, like right click the levels and then we insert the button there in the right click?
I don't know.
Okay.
You have to look at like Slate. Specifically with Unreal Engine, you have to look into Slate.
Slate.
All right.
I see. Okay.
What we do is we use a blueprint.
Oh.
Yeah.
And then that calls in the Python.
So it's
I
like
see.
Ah.
I see.
Yeah,
Okay.
right.
Nice.
Okay.
One of those utility.
Editor utility.
It puts it in the script actions when you write the.
Oh, okay.
Yeah.
Oh, I see. Okay, great.
Yeah.
Thank you.
Right click. Yeah.
Okay.
Scripted action.
Hi, thank you for the talk. You mentioned interchange.
Yeah.
Have you had experience with that, and what can you share with the onboarding? Because it's relatively new, right? It's interchange was a beta release in 5.6.
Yeah.
How does that impact your plugins and your workflows, and
Well,
have you had experience moving forward?
Like I said, I don't have now. We just started using 5.5, where things are experimental, and obviously they are, because when I use my script to import the FBX, I have some issues. It seems fine, but I have a few glitch. I don't get the physical assets when I import a skeletal mesh. I don't know why. So maybe it's fixed in 5.6. That's why I just give a heads up about it. I don't have answers. If you have, please tell me.
I thought you might have some experience to share, because I know it was experimental in 5.5.
No, not too much.
Thank you very much.
Yeah.
Hey, when you fire off the movie render queue right at the end, do you guys render on the workstation that actually submitted it, or does it go to deadline and get distributed or something like that?
No, we render on the lighter's machine.
Yeah, right.
That's why it needs to be fast. Yeah.
Have you guys looked into distributed rendering at all, or have you just sort of?
A little bit, yeah. But I'd say we are satisfied with the quality we get out of we have artists have powerful machines, very powerful machines, so they have the power to render the quality that we are good with.
Hi, I just want to say thank you so much for the very inspiring talk. So I'm not an artist, so I'm I apologize if my question is a bit dumb, but like one thing that I want to ask is, as a technical person, like as an engineer, I think the talk's very inspiring. How would you recommend for us engineers, people, to help out our artists with getting their workflow automated? Like, should we be reaching out to them and asking them, hey, what do you do on a day-to-day basis? Or do you have like a guideline that that you can just recommend of like, these are the things that you should just start automating for them?
That's a very good question, and you answered it. Yeah, asking them is the right way, especially if you don't know how they work. Yeah, you have to see how they work and see where they will need help and help them. So yeah, ask them. Yeah.
Okay, thank you very much.
Thanks for the talk. I'm just gonna ask. I haven't been developing pipelines in Unreal yet, but I have been in Maya. So I was gonna ask, do you use version control like Perforce for your assets and stuff? And how do you integrate it for the like asset importing, like the set dressing? Because I noticed that you only use like JSON, so the model files and so will be stored maybe not in the artist work machine, or maybe they're stored somewhere. How do you integrate it? Thank you.
Yeah, that's a good question. Perforce works pretty much on its own. The good news is you don't have to do too much. I do some stuff when, for instance, the script manipulate a lot of levels. I have some script that does check if the levels are checked out, and then if they are checked out, I stop the script. I do this kind of thing, but yeah, Perforce work on its own. You don't have to bother too much, which is very, very good. Yeah.
Hi, just a one question on that. Do you use Perforce on like the raw assets that you store, like for example, like all the FBX file and JSON? Are they under a different Perforce, or because I know like Unreal you can do Perforce to like version control the project, but do you do it as for the raw project as well, or is it like a separate storage method like as like a database or something?
Yeah, good question. Now, all the source files are on the server. Perforce is only for the Unreal project.
What do you use on for the server to store?
We have a big. We have an Isilon server. I don't know if that talks to anyone. Yeah, that tells you how much I'm a good IT guy. Yeah. All right, thank you very much.